instead of Genome.
Oh.
So you replace everything that people on Genome is using. Okay, I guess the best thing that I can do is just present this with the not presentation mode, and then move back to the videos time to time.
Yeah. That's weird.
Yep, but we need to start.
Because
So
if you use presentations mode, it should present the slides only.
yeah, no, I mean like the problem is like I can present, but every time that I want to show a video, the display is broke. So probably something related or with the system or with the LibreOffice that I am using. But it's not a big issue. I think Mari is going to be here in a minute or two. Mm. Sorry for the delay.
No, that's okay. The Echo 360 system is usually not okay to be used.
Why do you think so?
Because like every time the lecturer use it, there will be some small problems.
Hi, Mari.
Hi.
How are you?
Thank you. Sorry, I had difficulty finding this room.
No, it's okay. I am dealing with our issue with my computer, though.
Oh, you can be talking.
But it's okay.
This should be blinking, right? Have you tried this?
What?
This recording thing?
No, I haven't recording yet. Is recording or not yet?
It says recording.
So if it's red, then it means
Recording? Or green means recording?
yeah, streaming recording.
I am having a problem with this one as well, so
Yeah, okay.
if we can do two things on parallel.
Probably need a microphone as well.
Thank you for the help.
No worries. I just finished another class and it was late, so
Sorry.
I need to get that one.
Okay.
Just check something from here if others can see.
Okay, that is good.
That's all good?
It's not all good, but it's what we have.
To some extent good.
It's what we have at the moment. Then we're going to.
It looks okay.
Oh, you can see us? Okay. That's great. It's supposed to be green though. Does it say that it is recording or not?
It's,
So that it should.
it is recording.
Yeah, if it is on there, it should be recorded. Yeah. Cool. Thanks for that. So if we pause from here, do you think?
Yeah.
You know, seems to be
One more time, I should work.
Is it good from your side?
I think so. I mean, like I tried to do the projection, but every time that I do it, it breaks. So I'm going to use what we have.
Can you by any chance use that computer?
I
You wanna
have
stick with
everything in Linux.
Don't worry.
That is,
So I'll try this one as well.
thank you.
Or maybe just see if that works. You can hear from there as well, right?
Hello, 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 hello.
Yes, we can hear.
Okay, I'll just maybe introduce you quickly and then hand over to you.
Thank you.
Ready to start?
Mm-hmm.
Ready to start?
Give me a second.
Yeah, sure.
Sorry for the delay.
We don't have a camera here, do we? There's a camera over there.
Okay.
Okay, so good afternoon, everyone, and thanks for waiting. Sorry for a little bit of delay. Today we have Dr. Christian Rodriguez, and he's a research fellow at the Australian Institute for Machine Learning, working at the intersection of art and machine learning. I believe he has a lot of interesting stuff to show us. So without further ado, I think I'll just hand over to Christian. Christian, scene is yours. And
Thank you for the introduction. I guess first I have to say sorry because the presentation is not working properly, but I'm going to do my best to present. Yes, as Madis said, I am a research fellow at the Australian Institute for Machine Learning. My main topic, or the thing that I actually do, is video analysis, but I have done some stuff on art during the time that I have been here in AML. So the idea of this presentation or this talk is show you different things that has been created on machine learning, artificial intelligence, that are applied to art, and possible to give you something like a good insights of how to use what you're going to learn or what you are learning at the moment. If you want to move to you want to do something on art, right? So, but I guess the first question that I want to answer before to move to real technical knowledge is what is art? I guess before coming to here to the Australian Institute of Machine Learning, I didn't know anything about art. I mean, like, I enjoyed art. I listen music. I go to the theater. I watch movies all the time. But if someone asks me what is art and what is not art, actually I cannot answer. What is that? And I guess it's an important question to answer before trying to develop something. Do you have any idea of what is art?
It's hard to define this thing. It's kind of some creative. I think one aspect of art is creativity. So it must be some creative piece of work, no matter a drawing or music or sound. Maybe if you trigger a person's feelings,
That
if you enjoy or have some kind of happiness.
right, like I totally agree. But when I thought about that definition or that knowledge, that way to say what is art, I found myself saying, well, my coding is beautiful. And I have put a lot of effort and creativity in the way to do code, right? And I actually can find some books that say the art of coding or the art of...
That's right.
So it's...
Sometimes they say it's a combination of engineering and art. So
Yeah,
both sides of the...
yeah, totally agree. Like, I guess if I go to the definitions, Oxford say the expression of or application of human and creative skills. and imagination, typically in a visual form such as painting or sculpture, producing works to be appreciated primarily for their beauty or emotional power. Almost everything that you have said, right? Britannica say also something very similar, that are also called visual art, a visual object or experience consciously created through an expression of skills or imagination. So, but I guess I really like this definition from Wikipedia. Art is a wide range of human activities that involves creative imagination and aim to express technical proficiency, beauty, emotional power, or conceptual ideas. There is no generally agreed definition of what constitutes art, and this is constantly evolves, right? The three classes of branch is visual art, painting, sculpture, theater, and literature, music, films, and other type of media. And I think it's interesting to say that art actually impacts to us in any kind of thing that we do. So it's in every place, like marketing. When we look at these bottles has been done to create some emotional thing in you, like probably it's irrational, but that is the reason why some of the reason why you pick this bottle instead of the other ones. And there are a lot of theory about color theory and that kind of things that try to understand what people is feeling through the colors and what others are doing. So we have this type of typical art that I saw in the school, that we have this Van Gogh one painting, or we have Pablo Neruda poems that, by the way, is from Chile as well. I am from Chile. So I guess the question that I have after that is how tech has helped art previously. So I guess like we can see many different ways where we have helped artists to create new art, but the most interesting to me is probably the photography, and then moving to these things that is the movie, right? And that is without any machine learning or artificial intelligence. So we, as engineers, we have been in art, science, art is there, right? We are providing tools to someone to create something new. So White Walls, that is a webpage about art, say that tech has helped in any part of our in the development of art, but nowadays probably the most fresh materials that we can develop or that we can deliver new type of art is with data, pixels, mathematical and engineering formulas. So when I saw a video game, it's not just a video game there, right? We have these kind of things that are really, really beauty, and that actually we can understand what is happening there. So something that I want to say about this, do you know what is a procedural generated photorealistic landscape? So this word procedurally is something really interesting to me. So the way that the computer games has been developed is by taking pictures of textures, and then you have a grid where you patch this one, right? Like you say, well, this pixel or this patch, I have to copy in this portion. But the procedural, so that is very expensive in terms of memory. We have video games of 10 gigabytes because you have to store all these textures. But what procedurally does is actually create equations, mathematical equations that are able to draw this. So that are able to draw trees. So we know that, for example, if you want to create this pattern, you can create a cosine sine formulation for this pattern, and you only need to store this equation from where to where you want to compute this equation and let a GPU to generate that, right? So that is going to save a lot of money, and that is one of the ways that we are using tech or technology in art but without the artificial intelligence yet. So that is the transition that I am trying to do in this talk, going from the typical engineering stuff, moving to machine learning. So computer art is any form of art in which computer plays a significant role in production or display of an artwork. So here I have some videos that I really want to show you, but I don't know if this allows me to do it. Give me 1 second, please. So this is a project from people on Tokyo University. This is a mapping project where you have one of these things and it's projecting some shape in your face. The interesting thing to me is in computer vision we have something called destruction from motion, and what we do there is we create a shape of the object, but we assume that the object is rigid. So if the object is not rigid, let's say like this, that it can deform, it's really difficult to project something there because you are always projecting something that is rigid, but is shaping. You also have to change the way that you are projecting this. So they are doing something like that. They are doing no rigid destruction from motion for doing a live performance, right? So now imagine that you're in a theater and you want to characterize someone and you just project something in front of this actress, and then you have a new character, right? And I found this is very, very interesting and promising in the sense that it's just starting, and it's in probably what I will say in the intersection of artificial intelligence and old technology. I'm not saying that this is a solved problem of computer vision or not rigid, but I want to say that it's not using deep learning, not using machine learning. It's just using multi-view geometry. So this is another video. I'm not going to show this one, but it's the same idea, but now they are projecting tears and changing the emotion of this girl in the meanwhile that she's talking by using that technology, and this is 2020, so it's very, very new. So then I asked myself what AI, artificial intelligence art actually is, and I couldn't find any definition. Probably because it's new, right? But I can somehow extrapolate of what we have said before to this task, right? Any form of art in which AI plays a significant role in the production or display of an artwork. So if you have and I guess this is probably in the intersection or can use any of these things, right? Machine learning, deep learning, robotics, data science. And probably yesterday I saw a new, that Tokyo was creating this robot that is drawing and generating art. The problem that I have with these AR generation things is some of the definition that we saw at the beginning, saying that art is human-centered, is something that define a human. We are creatives, but no other species can do these things, right? I think when we put artificial intelligence in the pipeline, the definition should change, or we have to create tools that follow that definition. Okay, so far, what do you think about the AR and art?
It's very fantastic.
I think it will change the way people see art, and yeah, I heard that there's some news that the AI can generate some realistic art. Actually, the other person cannot tell if it's generated by machine or it's generated by an artist. So that's definitely will change this whole thing.
Yeah, I think it's going to change the whole things, but also at the same time, I am a little bit afraid about it. So it's a tool that we have to be very careful how to use it.
Like deep face.
Yes, like deep face. So I'm going to present one project that we are working on that I am very proud about it, but also I am very concerned about what is the outcome of that. Anyway, like this is one of the main projects that I saw in ICCV 2017, and when I start to look at art in the computer vision community, right? Probably this has happened before, but this is the first time that I saw something very, very impressive to me. So they create something called cycle consistent adversarial networks, and the idea here is like, can I do image-to-image translation by learning the way that I change the style of one image to the other image, right? So if you imagine, I know that I have a horse that is the input, I would like to generate a zebra. The way that they do it is by, this is the definition of what is a style transfer. It's a computer vision technique that takes two images and blend them together so that the results output image retains the core element of the content image. So the way that they do it is by leverage this GAN architecture. Have you used this? Do you have a knowledge about how GANs works?
Yeah, part of it. Like GAN is a generated algorithm that they can generate artificial image from existing image.
Right. So that is one of the applications, but I will say that the most general way to see GANs is like you have a distribution of data points, which come from this training set. So we know what is the distribution of points. And what we want to make is that this generator is able to understand the distribution of the real data points. So if you have noise points that has a distribution of, I don't know, a Gaussian, you actually, what you want this one is able to take the random noise and generate a Gaussian, because it's learning the data distribution. And with that, actually, you can create the image, because the distribution of the pixels is going to be, for example, if you want to create a face, the eyes of the data set that they try to create faces, the eyes are always centered in the middle. So the distribution of the eyes is always pointing in this position, right? The only thing that you need to learn is how to change the pixels surrounding that eyes. And that is what you are trying to learn with this generator. And the discriminator, what it's trying to do is saying that anything that comes from the generator is fake, and everything that comes from the training set is true. And by doing this is a min-max problem, right? Like what we're trying to do is like make the discriminator as good as it is to say this is fake, this is real. And we want that generator as good as it's possible to generate fake images that look similar to the training image. So this is a game problem. Yeah, and that is the min-max problem of when we try to minimize the error of the generator and maximize the likelihood of the discriminator.
I'm sorry to interrupt. Do you think you could maybe close those panes, please, at least?
Beautiful.
So that we-
Yeah, sure.
Yeah, and maybe the other one as well, if you don't mind.
No, come on.
'Cause
Yeah, anyway, I have it.
She that he was worried that it's not fully screened. So this looks better.
Yep,
Much better.
sure.
Thank you.
No, sorry for, I guess I have problems with the computer, but anyway.
This looks much bigger.
Okay, so I don't know if I can get,
It's actually as big as it should be. That's okay.
yeah, but the problem that I cannot go
Oh, you cannot go in between. Sorry.
next page.
Not a problem.
Okay, there you go. So in this cycle GAN, what they do is like, can we, so it should prepare some consistency between the input to the output. So what they want is like, the input has to generate an output, which is the distribution of another image. And if I create another function that takes this output and can reconstruct that X. So doing this cycle consistency, you can go from horse to zebra, zebra to horse, and then actually you can go from zebra to horse, horse to zebra. And that is the whole idea of how cycle GAN works. And they create something really nice, which is this. They were able to do something like this, right? So the network was able to understand the distribution of the horse and the zebra by looking different images that are not aligned and then trying to change, well, this is a horse, this is a zebra, the points has to be, the distribution of the brown colors has to be changed to these black and whites. And then we can use it on arts, right? So the idea now is here we have an input which is probably a photo or something, and we would like to create a Monet, a Van Gogh, a Cézanne. So now we can draw something that has been created by someone else, like the style of Van Gogh or the style of Monet, by just taking a picture of something and then create this style of. So the cycle GAN is something more general, where you try to create this cycle consistency that can be applied to many things. But one of those applications is this art project, where we can recover the style from the artist. Of course, we have some failures, right? So I guess, yeah, why do you think that we get this failure in this case?
Computer recognized that Putin is the part of the horse.
Right. I guess yes, that is the rationale, and I guess it's because there is no semantic on the pixels. It's just color, right? So the color of this brown is similar maybe to the skin, and then I just change the distribution of the colors. So another task where artificial intelligence can be used nowadays is like creating poems, right? So this is some poems that GPT-3 has created. Do you know what is GPT-3?
It's a model.
Yeah, like GPT-3 is a big language model. And when I say big is because it has millions of parameters and is bigger than BERT and has been trained with much more data. So I cannot really tell what is the statistics behind, but as far as I remember, they consume the amount of energy of one city to train this model. It's huge. And it's able to create this sentence, right? Which is actually looks like poems, but
sorry to interrupt. You might already have that in the next slide. But is there a proper metric to? Because it's really hard to say if this is real artistic work, right? We need an artist to say how artistic this photo is. Do we have metrics for that?
do we? I mean, in the sense that as engineer, we want to measure everything, but we were talking at the beginning that we don't know what is art. How are we going to measure something that we don't know?
You couldn't.
I mean, the
Value
artist.
art itself, even.
So,
Artists do, right? Mona Lisa. Everyone knows how much valuable that is.
but that is so subjective, right? I guess it's a lot of marketing. I mean, it's a great piece. I am not going to say the opposite way around, but if someone comes with something very similar to Mona Lisa, is bad picture? Actually, it is, because it's a copy. So how do you measure that this is really good and this is really bad?
Can we have those people agree if this is a good picture, for example?
So then you need to ask a lot of people if.
It's very subjective.
Yeah, it's very subjective. And one of the problems I have had on generative and stuff, that anything that is about generation is really difficult to measure. So, for example, when you use GAN for generate faces or any kind of image, at the beginning people was just doing qualitatively evaluations, and they moved to use something called inception resonance score. And the problem to me about the inception resonance score is that is biased to the model of inception. So if the inception is able to capture something, then you're creating a metric that is failing because inception is failing. But great question, because I didn't thought to put that.
Maybe it doesn't exist, right?
Yeah, it doesn't
We
exist.
don't know if the artist can actually put a number on that. I don't know, maybe they would.
No, look, when I was working on this art project, I found someone that was selling the invisible art this year. They sold this by something like 15,000 euros. And it was nothing. It was something that was here, and he was saying it's invisible.
Come on.
It's a concept, so it's really, really strange to me.
Have one of those.
It's so strange to me. So how they measure that, how they come with this value, no idea. So this is the transformer model, and this has been spread nowadays in every place, right? Like the idea behind is from the attention is all you need, and it has an encoder and decoder, and GPT-3 is using the decoder to generate text. And as I was saying, like they have a lot of data, 300 billion of tokens from text. And they are training this model by a typical unsupervised way where you block or mask one word, and then you use the neighborhood words to try to reconstruct this word.
LSTM.
So the difference with the LSTM is like LSTM is passing information through the sequence.
Yes.
So you have LSTM is a long short.
Long short-term memory.
Yeah, and the main idea there is like you have some gates that is saying how much memory, how much you have to forget from the past, and how much you have to forget from.
From the,
Yeah. Here in the transformer, everything is connected to everything. So the only thing that you have is this big attention matrix, which is the size of the input tokens. So let's say that you have a sentence that is 30 words. You have a matrix of 30 by 30 and looking for the attention between each of the words. And it's computing that attention to get a final representation that is good for the task. And usually the task is unsupervised at the beginning, and they move to the downstream task. The problem that nowadays people is facing with this model, and I guess there are a lot of research going on how to solve this problem, is memory consumption. This explodes really, really big when you have really long sequence. And there are a lot of branches, right? Like I would say that one of the main branches is memory consumption. The other is how to use what other has been trained with these 300 billion tokens. Can we create something that using this information is good for videos, is good for image, is good for audio? And actually they're proving that they can. They can transfer the knowledge from one domain to another. Okay, so this is another project that I want to show you, but this is from Google AI. So it's very interesting to me because I think it kind of shows how underdeveloped this is at the moment. So here the idea is you want to create music that is following your feelings. So you create something like a diary that say beautiful. It's not making sound my computer. Well, I don't know how to solve this. Give me a second. Maybe I can do it quickly. Yeah. Okay? But the problem that I see of this is did you find any difference?
Yeah. Like the previous sound is going up, and this This one is going down.
Okay, but it's not really. Yeah, I totally agree that it's going up and the other one is going down, but I think it's still a lot of work to do in this project. Like if you are able to do something like I really understand the emotions and start to create some sounds, it would be really amazing, I think. Because it's not because of this project itself. It's like imagine that you can create content that is looking your emotions. So instead of showing you a painting, I'm showing you the painting that you need to change your mood. That will be totally different, and that I think that is where data science we can do something really interesting. The problem is like we can condition people to do what we want, right? Okay, so that is one of the AI project, but this is another one that I really want to show you. Also from the Magenta group. So, okay, so what happened here? They give you a small piano and they say that they're going to create a bot that is able to jam with you. The only thing that you listen at the beginning was myself doing something really noisy, but when we play this, the last part is where the bot start to create the drums. So it would be nice. I think this is still underdeveloped, and I think it would be really nice if we can create something like, I would like to jam with Jimi Hendrix. So I play my music, and I have a machine that has learned through all the examples that we have about Jimi Hendrix, and we play, and we have a Jimi Hendrix playing with us, creating music with us, with the style of Jimi Hendrix, right? Or if you are an artist, like you would like to create some music and look how the other instruments should sound given my music that I am generating. And that is something that at the center, at the Australian Institute of Machine Learning, we are trying to develop at the moment. Playing with some musicians to create this type of jamming with other. So this is another project that I want to take a look with you. I don't know if we can listen here. I cannot listen anything, right?
Cannot output the new
We're not trying to make music making easier. We're trying to build some sort of machine learning tool that gives musicians new ways to express themselves. We're using neural networks in a novel sort of way. We're using neural networks to generate sound. Not the actual note that's playing, but the sound of the instrument. And one of the first projects we worked on was NSynth, which stands for Neural Synthesizer. The NSynth algorithm learns the core aspects of what makes each sound like it does, and then combine those characteristics, drawing a new sound that's not just a blending of the two original sounds. Okay, so the first surprise for me is that NSynth works at all, because it's technically a very complicated algorithm and one that was hard to train. And so we've needed to go from heavy math, big computers, and lots of code to something that musicians could play. And so another group at Google, called Creative Lab, took the sounds from NSynth and created a musical instrument. We call it NSynth Super.
that's like wild to me. Here's a flute. Here's a snare. I guess in the middle, this is what it sounds like.
Now it does feel like we're turning a corner of what could be new possibilities. It could generate a sound that might inspire us.
The fun part is like, even though you think you know what you're doing, there's some weird interaction happening that can give you something totally unexpected. What? Wait, why did that happen that way? This is our first foray into actually building.
Okay, so I guess like what I take from this one is like or what they are doing is like they are creating an embedding space using a lot of data of different audios. So they create a representation of each of this audio, creating a meaningful where all these audio are located. And then they look some space in the meaningful to create this music. And when you don't have anything in the middle, then you can create something totally new, an instrument that no one has seen before because it's the combination of two or more than that. So it's very new project, I will say, and it's one of the examples where Google is trying to create art with the machine learning and deep learning. So I guess before moving to what we are doing in the institute, I want to ask if we have a recess or something like that, 5 minutes or.
Yeah, I think we take break at 2. Is that the question?
Yeah, if we take break at 2, then we can maybe take the break now and then having this short little bit that we. Yeah, so like I really want to make this break between what we have seen now and to what we are doing at the institute, because I want to show you that, or I want to find this talk with saying like, or finish that section saying that we really don't know what is actually art, and we don't know how we can use machine learning on this. So meaning that actually we can do whatever we want, mainly. And there are many tools that probably we haven't used and I haven't shown here for doing art, but it's good to take a look if you are interested in art of what other people has done on this, and that is what I try to do with the first part of the introduction. Okay, so this is what we have done on ML. So the first thing that we did is like, the idea here is like we have an image, and from the image we generate a poem. The model that we use is GPT-3, and we put this web page online where we pass an image and it creates something like a lyric or a poem about this one. I have done this with my picture as well. I'm not going to do it online, but yes, it's very interesting how the model is able to generate different things and all the time something that is meaningful. The way that we do this is by we use an object detector that has been trained on Visual Genome. That is like we use FasterRCNN for this. So we extract all the possible bounding box, and for each of these bounding box, we take the unique label. Like we have all the possible labels in this image. We take just one of those labels. And we pass this to the lyric to generate, to GPT-3 to generate something conditioning that words. And that's it, like we haven't done any fancy here. The mainly thing is like how to connect two pieces of work, which is like faster CNN and GPT-3 to generate image to poem. And by the way, that picture is from Adley. We saw that dog in the street. So yes, that is the main thing. Like we have different objects, and we take one label which says person and one label that say other things, and then we pass it to GPT-3 to generate the image. The other project that we work on, and when I was working mainly during the first semester, was doing like a voice cloning. And the idea here is like we have a voice of someone talking anything, and we want to actually imitate and sound like this person. We want to have the same voice of that person, but now we pass a new text, and the machine has to be able to generate this new text or say this new text. And the method that we develop is based on TagNet too. And what they do, or the basic idea here is like we have three models. One is like a Mel generator. Mel spectrogram is a way to look at the frequency of the audio. We have a pitch predictor and duration predictor. So the duration predictor read each of the letters and try to say, well, this letter has to be, say, 1 second. This phoneme has to be, say, 3 seconds, and so on. So it's based on phoneme. This one is trying to predict, given the combination of phonemes, what is the tone? What is the type of tone that I have to put in that phoneme? So all of them has been trained with the typical CNNs and the mean square error with the values of the pitch and the duration. And these are the results that we have. If I can play it here, it would be really nice. So we have, for example,
the examination and testimony of the experts enabled the commission to conclude that 5 shots may have been fired.
Okay, so that is the original audio. That is what we want to generate. This is one of the models, one of the previous model.
The examination and testimony of the experts enabled the commission to conclude that 5 shots may have been fired.
And this is our model.
The examination and testimony of the experts enabled the commission to conclude that 5 shots may have been fired.
So it doesn't feel too much difference, but when we go to really long audio.
Development. He said that as recently as 3,000 years ago, people weren't conscious of their own thoughts, and they would hallucinate a voice and think that they heard the voice of God giving them commands or sometimes just words of encouragement. And he suggested that over millennia, the part of the brain in the temporal lobe that did that has atrophied into something small and seemingly useless like the appendix.
Okay, so that is original.
Oh, that's human.
Yeah, that is a human voice. That is original one. This is
He said that
machine.
as recently as 3,000 years ago, people were conscious of their own thoughts, and they would have
So the machine cannot generate that really long audio, and when we
He
move
said
to
that
our
as recently as
model,
3,000
actually we can
years
do it.
ago, people were conscious of their own thoughts, and they would hallucinate a voice and think that
This
they
is the
heard the voice
sentence.
of God giving him commands, or sometimes just words of encouragement. And he suggested over millennia, the part of the brain in the temporal lobe that has atrophied into something small and seeing them useless like the appendix.
So it sounds a little bit robotics, and it has some problems, but it's probably the second step on our algorithm to create something like a good voice cloning. Then I want to show you, this is Laurie Anderson, our art in resident. She is an award-winning of avant-garde artist. She has been doing Stanford lectures on art and working with us on how to create art pieces. She was asking to do something like a virtual avatar or something like herself, right? And then that is the idea of the voice cloning, where we need something like, we need to create a face and a human that is saying, like, I am here, and looks like is the Laurie Anderson, but actually is created by computer. And I don't know if you have seen this Wombo AI. Have you? Did you? Okay, let me check if I can open it.
It's raining men. Hallelujah, it's raining men. Amen.
Okay, so in this project, what they do is very similar. I just want to show you that this Wombo AI is like an application where you take a selfie of yourself and they put it in this face and they can sing anything that they want. So it's something like that what we want, but actually we want to make that the avatar is actually saying whatever we want. And people is doing this for different reasons, like the application that I was saying, but what we want is something like a person that looks like her, but is actually not, right? So this is another example. Let me check.
Just a perfect day.
Severe myopia contributed to Ron's inferiority.
So this is a first stage of the face cloning.
Severe myopia contributed to Ron's
We haven't put the voice cloning in the project, and the face cloning is just like a 3D shape of the face of Laurie Anderson. And then we finally finish with
Just a perfect day. Drink sangria in the park. And then later, when it gets dark, we go home.
okay, so this
Just a perfect day.
is the final thing that we have.
In the park. And then later,
We have a face that
when it
is
gets dark,
looking the shape, looking very similar to Laurie Anderson, and we have a voice that actually looks here and listen really similar to Laurie Anderson. And the way that we did like the face is by 3D models without not much machine learning. By the voice cloning is what I showed to you, but with a lot of data pre-processing. So we have to deal with a lot of data from Laurie Anderson and clean it and find a way to make it the model learn how she sounds, right? So that is mainly what I want to show you about the AI in IML. That is what we are doing at the moment, and that is how the resident is working with us. We have another resident which is Jamie Music, he's a jazzist, and he wants to make that the different instrument plays with him. And yeah, that's it. This is what I have for you. Like, what is, if you have any question or anything that you want to comment.
How can we generate like pure face?
What do you mean with pure face?
I mean, in the previously video, there's two
Just a-
face.
You are asking for the left one?
Yeah, the left one.
So those are models that has been created before. So you have 3D shapes of like a mesh of the face, where you have all these triangles, little triangles that say how the.
So they can use some of the sensors.
Yeah. But 3D models like computer graphics has done this for a long time. When you see computer games, you can see like a real face where you have all these like little triangles that are saying like this is a patch, and the only thing that we need to put is like this texture is related to that patch. Yep. So thank you. I mean, like that is the little introduction that I have for you about the AI in art and how we are using machine learning for art.
Thank you.
No, thank you.